All right, let's talk about something that is just maddening. You're paying for multiple internet connections, thinking you're getting the best of the best, but your online experience is still terrible? Well, today, we're going to show you how to take those separate connections and forge them into one single, seamless, professional-grade network that actually works. Let's dive in.
Does this hit a little too close to home? I mean, you're paying good money for count 'em, two high-speed internet lines, but your Zoom calls are a pixelated mess and you're still staring at that buffering wheel. It's a super frustrating paradox, and it is exactly the problem we are going to solve right now. So, what is going on here? That brings us right to our first section, the two internet paradox. It seems totally logical that adding a second connection should double your power, right? But what's really happening without the right gear is you're just creating two completely separate networks that are basically ignoring each other under the same roof.
Okay, so here's the absolute heart of the issue. The modems that your internet provider gives you, they're lone wolves. They are designed to work completely by themselves. They have absolutely no idea that the other one even exists. So they can't coordinate traffic, they can't share the workload, and they definitely can't act as a backup if one goes down. It's like having two separate highways that never connect.
Now, the source material for this explainer puts it perfectly with this analogy. You need a supervisor. You need one device, a central brain that can take both of those expensive 1 gigabit connections you're already paying for and intelligently weave them together into a single, massive, and totally seamless super pipe. So how do we actually build the super pipe? Well, it's time to assemble the A-team. And no, the solution isn't just one magic box. It's a small team of highly specialized hardware, where each piece has a really critical role to play in making this whole high-performance network a reality. All right, meet the MVP of this whole setup, the load balancing router. This is our supervisor. It's the brain. It's the piece of hardware that plugs into both of your ISP modems and takes over all the important thinking. It merges the traffic, it handles failover if one connection dies, and it becomes the one single gateway for your entire property. Okay, but what if your two internet lines are in totally different buildings? I mean, running a super long Ethernet cable can be a huge pain or just impossible. That's where a wireless bridge comes in. Think of it like a virtual invisible wire. It shoots a focused, high-speed connection over hundreds of feet with almost zero speed loss. Problem solved. And finally, we have the hub. Once our load balancing router has created that awesome internet superpipe, the core switch is what actually distributes it to everyone. It's like the grand central station for your network. Every single wired connection for every room and every Wi-Fi access point plugs right into here, making sure everybody gets a direct, high-speed lane to the internet.
So, what's this A-team going to set you back? Well, as you can see, we're looking at just under €700 for the main components. And look, that's not cheap, but for a business like a co-living space or for any serious remote worker, you have to think of this as a strategic investment in getting professional-grade, rock-solid reliability.
Now, we're getting to the absolute core principle that makes this setup so good. It's not just about buying the right boxes, it's about the logic of how you connect them. And here's the secret. In a world that is obsessed with wireless everything, wires almost always win.
Okay, just look at this comparison. On the left, you've got your typical wireless mesh system. The signal literally hops from one unit to the next to get to you. And guess what? Each one of those hops can slash your speed by 50%. It's crazy. But on the right, that's our star topology. Every single Wi-Fi node has a physical cable running all the way back to the central switch. It's called a wired backhaul, and it means you get 100% of the speed you're paying for at every single access point. No hops, no loss.
So the takeaway here is super simple but incredibly important. By running a physical wire from that central hub to each key area of your property, you completely eliminate the bottlenecks and the interference that just cripple those wireless-only systems, especially in bigger spaces. It really is the secret to getting consistent, gigabit-level performance everywhere.
Look, building the physical network is one thing, but you have to configure it correctly. And there is one huge, massive pitfall that can bring your beautiful new system crashing down. It's called the double NAT dilemma. Let's make sure we know how to avoid it. So what on earth is double NAT? Well, to put it simply, it's what happens when you have more than one device on your network trying to be the brain. See, your ISP modems think they're the brain, and your new load balancing router also thinks it's the brain. When they start fighting for control, it just creates total chaos for anything that needs a clean, direct path to the internet. We're talking VPNs, Zoom calls, and online gaming. They just break.
The good news is, this is totally fixable and it's pretty straightforward. Step 1. We give each ISP modem its own separate lane, its own little address space. Step 2. We create a brand new, clean superhighway for all of our devices. And step 3, and this is the most critical one, we put our Wi-Fi mesh system into what's called access point mode. This basically turns them into dumb signal repeaters and leaves our new load balancer as the one and only undisputed brain of the entire operation.
Okay, so we've built the network. We've configured it to avoid that massive bug. Now, it's time for the final polish. Let's add the professional touches that take this system from being just functional to being absolutely bulletproof. Here are 4 quick, high-impact tweaks. First, if you're running cable between buildings, use fiber optics. It's totally immune to electrical surges from things like lightning. Second, lock down the IP address for each of your Wi-Fi nodes. Trust me, it makes troubleshooting way, way easier later. Third, change your DNS settings. Get away from your ISP's default and use a faster service like Cloudflare or Google. And finally, you have to enable the auto failover feature on the router. This is the magic that means if one of your internet providers goes offline, the other one takes over instantly, and nobody on the network will even notice. And that really brings us to the ultimate point of all this. This project isn't just about chasing the highest possible number on a speed test. As the source material says so well, digital nomads require stability. For anyone whose job, whose entire livelihood depends on their internet connection, reliability is everything. And this setup, this architecture built on a wired backbone, is how you guarantee that 100% of the speed you pay for is delivered with rock-solid stability to every single corner of your space. So it leaves you with one question, really. Is your current network an asset, or is it a liability?